My name is Jamar McDonald, and I am one of the MBSE specialists here at GoEngineer. And today we'll be having a webinar about the MBSE advantages, driving efficiency and innovation in systems engineering. So first we will start with our agenda for today. We'll be going over MBSE to really understand the intent behind it and why a lot of companies have started to adopt it. From there, we'll start on discussing the MBSE pillars and a couple of plugins that are available with the specific tool that we support here at GoEngineer. We'll have a quick overview of those, and then we'll really dive into the advantages of the MBSE pillars and of course the advantages of the plugins with Magic Cyber System Engineer, which is the tool that we support. And finally, we'll have a closing to review everything that we've discussed in the webinar. So starting out with understanding MBSE. So first we should discuss that a lot of other disciplines already have modeling software that they use, whether it be thermal, fluid dynamics, electrical, or mechanical. They all serve a purpose of developing and really understanding systems before they get into the physical build process, and really doing a lot of like gap identification and really understanding if all the requirements of the system are being met. And this is the same purpose of model-based systems engineering. We are moving systems engineering to a model-based environment so that we can have fluid traceability, as you can see with the green subsystem A, moving from a block definition diagram, understanding how that subsystem fits into the entire system and how it is connected to the other subsystems, what elements or energy might flow in between those different subsystems and different components. And so the entire purpose and intent of model-based systems engineering is to have that single source of truth, so we understand if we are meeting the requirements of the system and really understanding how the entire system is being built before you actually go into these disciplines such as thermal, fluid dynamics, electrical, mechanical, and all the other disciplines that come after. We really understand what the build is for the system. So INCOSE has a definition, and that is the International Council on Systems Engineering, and they define it as model-based system engineering is the formalized application of modeling to support systems requirements, design, analysis, verification and validation activities, beginning in the conceptual design phase and continuing throughout the development and later lifecycle phases. So really the purpose of model-based system engineering is to graphically engineer systems, integrate information from different disciplines. As I mentioned, having that single source of truth and really understanding and having version control over your project as it goes through its life cycle. Identifying gaps through graphical analysis and simulation, which we'll get into through some of the plugins that are available with our specific tool. And then identifying risk, issues, and opportunities early in the design process. And we'll kind of go over that in our review slide as well. All of these advantages that we're going to go over really support moving everything to the left, whether it be your time or your cost, and really avoiding a lot of that risk and technical debt that can build up in your projects if you aren't using a model-based systems engineering environment to develop your projects. So now that we kind of went over what MBSE is, we'll go over the pillars and also some of those tool plugins, just a quick overview before we dive a lot deeper into them. So there are three pillars of model-based systems engineering. The first one is the language, and this is the graphical language that everyone uses whenever they're doing model-based system engineering, so that we're on the same page, and we'll really talk about some of the advantages of that as we move on through the presentation. The second one we have is the methodology. And this is how you employ the language. The language by itself does not give you a specific architecture framework, which we'll kind of talk about as we move on later as well. or how to go about creating your system. Where are you going to start? How are you going to store your requirements or your stakeholder requirements? Where are they going to go? And so that's really what the methodology is for. And then, of course, the tool that you use is going to combine the methodology with the language so that you really have that single source of truth as you're going through. It keeps you compliant to the language, and it gives you that version control, as well as allowing collaboration with whether it be internal or external collaboration. So on the tool side, there are 3 plugins that we'll be discussing today. There are a lot of plugins that are available with Magic Cyber Systems Engineer. These are just the ones that we decided to focus on today, as they are very popular ones, some that you might be interested in. So the first one is Data Hub, and this is your requirements synchronization plugin. This allows you to have bidirectional synchronization between the modeling tool as well as your requirements if you want to keep those external. You can house all of your requirements in the modeling tool in the modeling environment. It is great to do so, as you can verify some of those through simulation as you go down to the Magic Model Analyst as you go throughout your production process. So Magic Model Analyst is the simulation toolkit. This allows you to do simulation of your activities and also kind of do some requirements verification, automatic requirements verification. And so those are some of the advantages that come along with simulation, allowing you to do a lot of that verification before you actually get to your build process. And this is one of the significant things that allows you to have a lot of that savings as you move forward in your project. You don't have to wait until you have a physical product in your hand to do a lot of that testing. You can really do that in the beginning stages of the process, which allows you to cut down on your risk, cut down on any technical debt that might come up, or any fixes later on in the project that have you go back. You're really allowed to really cover all your bases early on in the project. And then finally, the big one is Magic Collaboration Studio. This is what allows that simultaneous modeling from all of your different engineers on the project, as well as some other things. And we'll really get into a lot of the advantages of having Magic Collaboration Studio. It is highly recommended to have that, regardless of the number of engineers that you have working on your project. So one thing I do want to address is the different portfolios. So a lot of people know Cameo, and I just want to address that so that everyone can really understand that there are really 2 portfolios that you're working with. Magic, which is on the commercial side, and then you have No Magic, which is on the defense side. The software is really the same. There is just a different bundling of the plugins that are available, as well as different naming. So whenever I say Magic Collaboration Studio, that is the same as Teamwork Cloud. It's just a bundle of Teamwork Cloud and Cameo Collaborator. And so you get those 2 in 1 on the commercial side. Magic Model Analyst is the exact same as the simulation toolkit. And then you have the 3 standard products. And so Magic Software Architect is the same as Magic Draw. These are both based on UML if you're doing any software modeling. And then once you move up from that stage, you get to SysML, which is, to simplify it, is basically a build on top of a UML with some changes, some things pulled away, but it's the language that systems engineers use to do model-based systems engineering. And so once you move up one step from that, these 2 are the same except for the plugins. So if you are doing any if you do want to use UAF or DODAF or some of those other military-focused architecture frameworks, then you would need to use the top level of the product, which will still allow you to do that model-based system engineering. But what we're discussing, so when I say Magic Cyber Systems Engineer, it is the same software as Cameo Systems Modeler. But I just want everyone to be aware of that as we move forward. All right, so now we can really talk about the advantages of the pillars. Why are there the pillars of model-based systems engineering? And the first one is the language. So if you look to the left, you can see that I have the same subsystem with its components But the associations are different. One has a diamond on the end connecting. The other one has no diamond with the arrow. And then the final one, there is just the association with no diamond or arrow. So the advantages of having a common language are the quick onboarding and internal understanding, as well as customer and supplier collaboration. So someone who understands SysML will be able to come in and view your model and instantly be effective on your team without there being needing to be a lot of conversation about what different symbols mean, how your entire project is or your system is built, or even how some suppliers fit in. If we understand that component 1 is coming from one supplier and component 2 is coming from another, your new onboards who are familiar with a SysML will be able to come in and be effective and really understand how your entire system is put together. Even if you are supplying the components to a larger system, this allows that customer and supplier collaboration. Because a lot of people are moving to a model-based system, we're able to send these models over and really instantly be able to understand the interfaces and everything that is communicating between the components or the different systems. And so that's the reason for having one language. So it really skips the conversation on why do these diagrams look this way and what is a block or things of that nature. And so that's really the basis, is having that common language. And then once you move on from the language, you really need to have a methodology. And so the way that your model is stored is basically a file system, and this is called the containment tree. And so this is where all of your elements truly exist. This is truly your model. All of the diagrams are just a representation or a view of your model, but this is really where your model exists. So your methodology, and this is the Magic Grid framework, and so we'll talk about some of the advantages of this specific methodology. But your methodology is really how you're going to go about building your project, what steps you need to take, and also how you're going to organize your containment tree. And some of the advantages of using a specific methodology, even if you come up with one and documenting that properly, will allow for the simplification of large model navigation. And you can imagine that as you get up into the millions of elements, it can be really hard to navigate and for people to understand the structure of your model. But if you are using one of the common methodologies, then again, as I mentioned, new hires or people who are coming over to work on a project who might be migrating from another one really be able to come in and kind of go through the model and understand for themselves really what's going on the project. And outside of the architecture framework, it also allows for a pathway for completion. And so the Magic Grid framework, as I mentioned, allows you to go from the problem domain to the solution domain and really go through all the steps of acquiring your different requirements and really understanding how you need to build out your system structure to align with those requirements, as well as allowing that traceability. And so that's another advantage of having your requirements and your modeling in the same platform. It really allows for that traceability between everything. And again, this allows for easy integration with suppliers and customers as you move through your different phases in your project. You really understand what phase you're in, so when you do get a model or send a model, it can easily be plug and play to really understand if that is meeting all the requirements of your project. Now, for Magic Grid specifically, there are a couple of additional advantages. So the Magic Grid framework was developed by Dassault, Cameo, and Magic Cyber System Engineer are Dassault products, and so that the Magic Grid framework is free to download. Firstly, and secondly, there is a sample model walkthrough. And so since you are getting the tool and the methodology from the same place, you also have the completed sample that's available in the software. So when you go through that walkthrough, it'll allow you to really understand some of that basic functionality of the tool. So it's really you're really getting double the bang, because you're able to understand the methodology while also understanding some of the tool functionality as you go through this methodology. So I highly recommend going, and we have this available on our website if you're interested in downloading this. And we can definitely set up demonstration as well for this if anyone is interested. And finally, we have the tool. And again, as I mentioned, it's the tool that you use is very important for implementing model-based system engineering. Some of the advantages of having a tool or the language compliance, and of course the model synchronization. As you can see, if you try to create some relationships that are illegal according to the language, Magic Cyber Systems Engineer at least won't allow you to create those relationships. So you won't be allowed to create any illegal models. Now, it doesn't necessarily stop you from creating bad models, of course, but you won't be able to do anything that is illegal. Again, that model synchronization also allows for anytime you make changes to one part of your system, it flows throughout your entire system. So you don't have to worry about updating any of your anything based on changes that you make somewhere else in the model. Now, for Magic Cyber System Engineer specifically, it does have that digital thread readiness. So one of the things we're going to talk about is Data Hub, which allows you to connect to some of those requirements management tools. Of course, there are a host of plugins. We're only going over the three biggest ones today, as well as it being the industry standard. A lot of people have heard of Cameo. Whenever you mention model-based system engineering, DSO usually comes up. Magic Cyber System Engineer comes up, Cameo comes up, maybe even Magic Grid for those who are unsure of the differences. And so having a lot of the tools having this tool being an industry standard really allows for that connectivity, sending the same files back and forth to each other, or that collaboration. And additionally, you have the support resources. So if you do happen to have your licensing through us, you have the support of me and the other MBSE specialists, as well as the full support of DSO. We have a direct line for any support cases that may come up, and they're always having new releases, new refreshes, and working on really making the tool the best that it can be as model-based system engineering continues to mature and develop. And so now we can kind of move on to some of the tool plugin advantages. And the first tool we'll be talking about is Data Hub. Requirements is a huge part of system engineering. And so, of course, it is a huge part of model-based systems engineering. And one of the big things that DSO really wanted to implement was not a rip and replace, but really expanding your digital thread. And of course, all projects start with requirements. And a lot of people use Jamar, a lot of people use Doors. Some may be using the 3D Experience platform, or some may even be still using Excel. And so you're able to have a bidirectional or a single directional synchronization between your requirements in the modeling tool and your requirements wherever you choose to host them. Now, you are able to create all your requirements and manage all of them in the tool. Model-based system engineering does account for that. But if you are looking to keep any of your requirements management tools, then you're able to do that. As you can see, you can have different your update status based on whether anything is new or when anything is has been pre-existing or changed. And so this really allows you to keep that single source of truth while also having the data available in different locations. This also allows for that version control, as I mentioned, which allows you to really understand the changes, any changes that may be happening in your requirements as you go throughout your systems engineering process. So the next advantage is Magic Model Analyst, which is the simulation toolkit. And the simulation toolkit really allows you to understand your function, do a functional analysis and gap analysis. There are a lot of benefits that come with simulation and really understanding if you're creating your models the way that you expect them to. Sending your different signals, as you can see here from your different systems. My apologies. Sending your different signals to the different subsystems and really receiving those signals and really understanding how everything is functioning in your model. So this really allows for that gap analysis. There is also requirement verification, some automatic requirement verification that can happen if you have some value properties that you're trying to understand or doing any trade studies. say you have two components that you're really trying to understand how they fit into your requirements. As you run through your simulation, this will allow you to verify some of those early on to really understand, what fits best in your project as you go through. And so a lot of companies are definitely taking advantage of the simulation. As I mentioned before, there's a simulation and stress analysis, there's simulation and mechanics. So everybody is really getting on to understanding that simulating before you get to that build stage really helps with maintaining that risk and maintaining that technical debt. And so now we're really trying to bring that to the system engineering realm, which is really kind of behind if you really think about it. Everybody really has all their modeling platforms, and so we're trying to get really up to speed with a lot of the other trades that are out there. And finally is Magic Collaboration Studio, and this is really one of the big ones that a lot of people are using. So Magic Collaboration Studio, or Teamwork Cloud, it is a on-premise tool that allows you to host all of your projects on your servers so that multiple engineers and even different stakeholders can have access to all of your models at the same time. So it allows you to have different modelers working on different sections and be continuously updated with anything that's happening. If you have a requirements team that is separate from your architecture team, you can have all of them working on the project and updating at the same time and be updated in real time about any changes that are going on. Another big one is the review process that you can have with Collaborator. So it's not necessary when you have Magic Collaboration Studio to have the tool downloaded. Any non-engineers or any external stakeholders who just want to look at the models to really understand if the engineers built it the way that they envisioned it happening, you're really able to do that. You're able to have publish that, quote unquote, publish that, and have that available in a web browser for anybody who is any non-modelers to really review. And another big one with Magic Collaboration Studio is the project version control. You don't really have this if you don't have Magic Collaboration Studio. And so every time that you save your model or you commit your model to the server, it saves a new version. So you're able to kind of walk that back if there are any versions that you need to do that on. Otherwise, if you don't have Magic Collaboration Studio, it really is just on the personal machine of whoever has the tool. It's kind of saved like a file. The data is on the personal machine, and you are able to send that back and forth. So even if you do have one person who is your system engineer, it's still beneficial to have Magic Collaboration Studio just because of that version control. And also the project reuse. It's a lot easier to reuse a lot of your foundation on your projects whenever you are using Magic Collaboration Studio and really creating those new projects and having that extra benefit as you go through your model-based system engineering process. So I highly recommend looking into Magic Collaboration Studio. Like I said, we are definitely able to do any demonstrations that may be necessary. So that's definitely something that a lot of companies are looking into and grabbing a hold of. So that concludes some of the things that we want to go over in this webinar. Again, there are 3 pillars of model-based systems engineering: the language, the methodology that you choose to adopt, and the tool that allows you to implement that language and the methodology. Again, the tool that we support here at GoEngineer is Magic Cyber Systems Engineer. If you are interested in learning more about that, you can head over to our website, and you're able to find a lot of information on the differences between the tools and some of the plugins. We also have a buyer's guide if you're interested in what the process looks for that. And of course, you're always free to reach out to some of our sales members or me directly to understand or get a demonstration on what exactly everything entails. With Magic Collaboration or with Magic Cyber Systems Engineer, there are a host of plugins. The 3 that we kind of went over today are Data Hub, Magic Model Analyst, and Magic Collaboration Studio. Those allow for your requirement synchronization, expanding your digital thread, and some simulation, some verification, gap identification, trade studies, a host of things that you want to do before you get to your production phase. And then, of course, Magic Collaboration Studio, which allows you to collaborate with other engineers, other stakeholders, and really have that repository for everything that is going to happen during your model-based systems engineering process. And of course, all the benefits that we have laid out in the pillars and the plugins and adopting model-based system engineering goes towards that long-term goal of saving time and cost. And this kind of goes hand in hand with some of the complexities. As you can see in this image here, whenever you move down to the model-based system engineering process, you're really extending your systems design phase and your systems integration phase, taking on a lot of that risk in the beginning stages of the project, whereas your risk really goes higher traditionally, because once you get to the product integration stage, if you don't really have a well-defined system, a lot of those can really add to that technical debt and that risk and that rework that you're having to do in that stage. And so by moving all of that to the system design phase, doing a lot of your verification through simulation, you're really able to save and shrink down that product integration phase and your testing phase as well, if you're able to verify some of your requirements through the simulation toolkit or Magic Model Analyst. Now, of course, these definitely come with some complexities. So the first big complexity, of course, is learning the language. It is recommended to have somebody who is familiar with the language on your team, but we definitely have customers who go through trainings. We have some great partners who offer excellent training on the language and walk you through an entire example on how to build out a model. And so there we do have some customers who are going through that process and training somebody versus hiring somebody who already has that knowledge. But either way that you go, there is going to be that learning curve for the language, as well as a tool if you're not using the tool yet. Of course, you can cut down on some of that with, as I mentioned, the Magic Grid framework. It allows you to have some of that tool functionality. And of course, going through the trainings will help with that as well. And just in general, the transition, the version control is going to be something new if you're not in a model-based environment so far. How are you going to do your federation? Are you going to separate your requirements projects and just use those in your other projects? Or, how are you going to go about maybe branching your model and having people work on different phases or different features? And transitioning really from Excel, or maybe even extending. Of course, we mentioned that this is really to extend your digital thread. So some companies might seek to expand the digital thread and really just implement model-based systems engineering along with the tools they're already using. And some of them might choose to, really rip and replace and use this as your requirements management tool as well as your model-based environment, and really have it as the single source of truth as you move through all of your phases of your life cycle. And so those are definitely some things to think about. There is that upfront cost and understanding that this is going to take time to learn. But as we mentioned, a lot of companies are moving towards model-based system engineering because of those long-term savings, because of the project reuse, because of the easy integration, allowing you to really understand all of your interfaces between your different subsystems and components, as well as interfacing with suppliers and customers who are also using the tool and in a model-based environment. It really allows all of that cohesiveness to move it into a single platform. And so those are a lot of the benefits and advantages of moving to a model-based system engineering environment over a traditional systems engineering experience.